Time literally stops inside a black hole. Sounds like science fiction, right? But this isn't a theory. It's what Einstein's general relativity actually tells us. Let me explain. Imagine you're floating in space, watching your friend fall toward a black hole. As they get closer to the event horizon, the point of no return, you notice something strange. They're moving slower, and slower, and slower, until they seem completely frozen, right at the edge. No matter how long you watch, they never fall in. They just hang there, forever. That's time dilation. The stronger the gravity, the slower time flows. And at the event horizon, gravity is so intense, time literally stops. From your point of view, your friend has reached a wall in time itself. But here's the twist. From their perspective, they don't feel a thing. They pass the event horizon in seconds. No freeze frame, no pause. They fall inward, toward the singularity. But for you, watching from the outside, that moment at the edge lasts forever. That's the weirdest part. Time is relative. It's not the same for everyone. And inside the black hole, the laws of physics as we know them collapse. Space and time switch roles. Going forward in time is now like falling into a hole. Unstoppable. Once you cross that line, you're not just trapped in space, you're trapped in time. This is why black holes are so terrifying. Not because they crush you, but because they bend reality itself. Time has a limit, and black holes are where that limit is reached. So if you ever find yourself falling towards a black hole, there's only one thing to say. Time to go. 1, 2, 3. Oops, too late. That was our black hole intro. Now for some quick hits. What's happening to all those poor souls trapped inside black holes? Well, according to our theories, they get stretched and distorted until they form a thin pancake called a 2D surface. That's pretty messed up. But wait, it gets weirder. At the center of most galaxies, including our own, lies a supermassive black hole. And scientists think these black holes might play a key role in the evolution of galaxies. How do they know this? Because they can actually hear them. Yeah, seriously. Black holes don't make noise, but they do cause vibrations in the disk of hot gas around them. These vibrations emit gravitational waves, and by studying these waves, scientists have learned a lot about the black holes and the galaxies they inhabit. For example, one team of researchers found that the supermassive black hole at the center of the galaxy M87 has a mass 65 billion times that of our Sun. Another team used gravitational waves to create the first ever map of the black hole at the center of our Milky Way. Yeah, it's pretty incredible stuff. We've come a long way in our understanding of black holes, but there's still so much we don't know. Like what happens when two black holes collide? Scientists are working on that. In fact, last year, the Nobel Prize in Physics was awarded to the detection of gravitational waves. Who knows? Maybe one day we'll be able to harness the power of black holes ourselves. All right, thanks for watching. See ya.